All right. So today we learn about queues, another data structure, another linear data structure that we were going to cover in this session. And yeah, we'll do the coding part after the theory explanation as usual. So what exactly are queues? What are they? Does anyone has an idea what the queue word means? Anyone? No, no. So, queues are, the lining system that we use in general life. May it be a queue outside a restaurant or a waiting line, something like that. So that is what queue means. And it works the exactly same way in Python also. That is, if you've been into a queue, what happens? The first person comes in and stand, then the second person comes and stands behind the first person, and the third person again comes and stands behind the second person. After some time, the first person exits the line. Uh, then the second person would exit the line, and then lastly, the third person would exit the line. So this is called the FIFO structure. That is first in, first out. That is whoever comes in the first goes out the first. All right. So that is the basic working principle of queues. That is the FIFO structure. Whoever comes in the first has to be served the first. May it be a restaurant, may it be Python, may it be any shopping mart queue. FIFO is always applied. Now, what are queues made up of? We can make queues through nodes. We can also make them through linked list. Singly linked list, we can make queues through them, and we'll add these functionalities, those functionalities that the queues have to those singly linked lists also. Similarly, today we'll make the queues from nodes. And let's see what happens. Now coming to the functionalities of queue. What queues actually have different from other data structures? What are the major functions of a queue? So majorly there are three methods or three functions or three functionalities that queues provide to us. The enqueue method, what the enqueue method does it adds to the queue. And where will it add? It will add from the behind, because that is the concept of queue, to add something from behind. In the first example, first pictographical representation, you can see Anne was there first in the line, Bob was there second in the line, and when we enqueue, Charlie is added at the third place to the tickets counter. The second function is dequeue. What dequeue does is it removes an element from the queue. So which element, as per the concept of queues, we could only remove the first element from the queue. So and gets removed when we use the dequeue function. Now the third function and the easiest one is peek. So what peek does it is simply shows us who is first on the list. It does not remove it. It does not add anything. It simply shows us who is the first in the list. So when we use peek on our example queue, Bob will be the result. That it will show that Bob is the first person standing in the queue who will exit next. Now, similarly, whenever we have functionalities, we also have some issues that come along with them. So in queues, we have two errors or two corner cases that we need to, really consider when we are implementing queues. One is queue underflow, and the other one is queue overflow. So what is queue underflow? Queue underflow means that if you have an empty queue and you are trying to use the dequeue concept, it won't work, and it will cause an underflow problem, under the queue underflow problem, because the queue is empty and you are still trying to remove something from the list, from the queue. Also, the another one is the overflow, the same overflow that you heard in the website named Stack Overflow. So what that problem is, for example, we have a queue of a limited quantity. For example, a queue is of like 10 maximum quantity, and we try to enqueue another element to the queue. So what it will cause a overflow problem that the queue is already at its max capacity and you are still trying to add something. So these are the two corner cases, that is queue underflow and queue overflow. Similarly, we've already discussed how queues can be implemented. We can use the nodes or we can use the linked list. So yeah, and then we can put constraints. That is, we can put some max capacity over a queue. So those types of queues are called bounded queue because they are bounded by a memory constraint. They are uh, constrained by a memory. So this is it about queue. Do you have any doubts on the concept itself, or else should we move to the coding part?
Bhaiya, isn't there another queue where we can add from the front and as well as from the back?
we we can do that. I mean, in the Python we can do that, but that won't that won't give us the functions of a queue. That would be something it other than queue. I mean, it will then act as a doubly linked list, won't it? Like where we can add from the front and also at the back. Then it won't be actually a queue.
Actually, I used to know that DQs were like queues in which we could add from the front and back and also remove from the front and back.
Acha, you are trying to say, oh, all right, all right. You are trying to say that there is a type of queue where we could add from front and behind, uh,
Yes.
remove from front and behind. Yeah, there could be. I mean, I've heard of some queues. This is the simple queue that we are, implementing today. We could also have circular queues where, for example, consider the example given in the slide. Charlie, Bob, and Anne. So there could be some queue where Anne could be again connected to Charlie. So or Anne could be again in some way. So that would be some kind of circular queue. Then we also could have a priority queue. We also could have a double-ended queue. Where participants could be added from both the sides or removed from both the sides. But the common concept of queue is that we have a FIFO structure, so that is what we mean by a simple queue. Then there are, of course, modifications. As we already also saw in linear search, there were modifications as per our usage. But the general concept of queue goes by the FIFO structure itself. I could send you some links if you want to read more on it. But yeah, yes.
Okay.
Anything else? Did you get it now? We can have types of queues. I mean, we can modify these programs and we can have, but the general concept is the one I just told you.
Okay.
All right. So, does anyone else has a doubt? Otherwise, let's move on to the coding part. So for queues, instead of the usual node methods that we already have, I also want to, apply some more methods so that we can actually, make the queue a little more for like a little more easier for our purposes. So since we have not actually in this program, since we have not actually, coded this whole node class over here, it is in another directory. So we will have to import the node class. So for that, we can simply write from node class, from node, import node. From this node.py file, we are importing the node class, this class. We are only importing this class. This whole class will is here. You can now say that it's all here. So for the basic functionalities, I want to have like similarly to the functions that we have in Node, right? Set a next node, get a next node, get value. I also want some in queue. So what do I want basically is I want to add 2 or 3 properties. So the first property is the size property. So I want to add a size to the queue so that I could make a bounded queue and I could tackle the overflow and underflow problems. Also, I want to I want to give it a max size. Also, I want to make a size variable so that I at all times I know what is the size of the queue at that point. All right. So I need 2 new variables. Also, I need 3 more functions. So first function would be get size function. I need to know what the size of the queue is. So this function will give me the size of the queue. The second function is the function is empty function. This function, what this function will do is it will tell me if the queue is empty. So if I print, for example, 2 is a queue and the queue class. Sorry. Queue is a object of queue class, so I can use then queue is empty. So this function will tell me if this queue is empty or not. So this is the second function that I want is empty. Then I also want one more function has space or not. A function that will check if the queue has some space or if it doesn't. Is it filled or not? So this will help me tackle the overflow problem. And this empty function is empty will help me track the underflow problem. All right. And get size is the general function that I could use to, get the size of the queue at any point. So these are the new things that we will do in the queue. So let's initialize the queue class and make a class named queue. Guys, there's some network problem over here. So just let me, my voice crackens a little bit between sessions. So just let me if that happens to us. All right. So let's initialize a queue class. In this, we again have the self, the queue itself. Then we have a max size. All right, we have to give our queue a max size also. But in case we don't give, I'll set it to none as none on default. All right. So while initializing a queue, we can give it a max size also. Now I need the head of the queue. I need to know the head of the queue. I can set it to none as of now. I need to know the tail of the queue. Again, I'll set it to none. Also, I need to have the max size. So this line would give the queue its max size. This will equal to again max size only. Also, what else we did? We wanted the size. So self dot size. Size. अभी तो queue का size would be 0. since it's the beginning. You get no difference between max size and size. For example, I've made max size. It has values 1, 2, 3, 4, 5, 6. Okay. So the size of the queue is what it is 6 as of now. But the max size could be whatever I've given it. So I can give it a max size of 10 maybe. So max size is 10, but the size of the queue as of now is 6. So this is the basic difference between the max size and size variable. Size gives the size of the queue at the instant, but the max size is the constant value, the max size of the queue, the maximum number that we can have. All right, so this was the constructor. We defined the constructor. Now let's get onto the methods. So before I, develop the enqueue, dequeue, and peak methods functions, let's define those get size, is empty, and all those other functions that we discussed. So let's do that. Let's define the get size function first. Get size function. It will only take self. It is only taking the cube. Can someone just dictate me what this will return? What will this return? Please.
Size of the array.
So what should I write over here?
Self.size.
So
Okay. It will return me self.size. The second method was is empty. Empty. So what it will take? It will again take self. Whatever we need. So इसमें what we can do, we can simply use the common logic. If the queue is empty, then give me false. And if the queue is empty, return me true. And if it is not, then return me false. So basically we can use if self dot size, the size at the instant moment is lesser than or equal to 0. Okay, if it's lesser than equal to 0, then return to me true that list is empty, else it will return false. So I need not write that. You can simply say return me false.
while less than and equal to 0, like size can be in
Yes.
size can be negative also.
I mean, just in case if sometimes we don't when the queue is empty, the program sometimes tends to give it some garbage values. So those garbage values could be negative also sometimes. Usually it doesn't happen in Python, but in C or C++ or Java, it often happens that the garbage value is there. But for to remove that, we already did it equal to 0. So this won't happen. So we can remove the lesser than equal to sign. But just for a habit, we should do it. So if I got it now.
Yes,
So अगर size अगर empty है, तो it will return that yes, the queue is empty is true, and else it will return as false. All right. Then what was the last function? Has empty. It was has empty function. What did it take? Does anyone remember? Oh. Will it take another parameter? Tell me, guys. Which parameter will it take? Anyone?
values.
Oh, it won't take any parameter because has empty. What will it tell if the queue is empty or not? उसके लिए हमें size की जरूरत है, तो size parameter तो we already have a. We will use the max size in it. So max size, the parameter is already in the class, isn't it? So we need not give something extra. So for that, we need not, use anything. तो क्या करेगा ये? If self dot max size equal to none, मतलब अभी self का max size नहीं पहुंचा है, तो it will return us true. Else what will it do? ये return करना चाहिए false. So either we could write simply false, or we can say that self dot size dot max size is greater than self dot size. This basically means that it has some space, right? Has space. All right. Now let's get on to the actual functionalities of queues. So this is one done with the redundant methods that we just needed to make enqueue, dequeue, and peek functions. So now let's make them. First function is the function. Let's make the enqueue function. And
Yeah. ये has empty वाला function फिर से explain करोगे?
has space वाला function हमें simply ये बताएगा कि क्यू में स्पेस है कि नहीं. तो अगर सेल्फ का मैक्स साइज इक्वल टू नन है, मतलब कुछ साइज सेट ही नहीं किया है, ठीक है, तो फिर तो हमेशा ही ट्रू रहेगा. ठीक है, यू गेट इट? मतलब अगर मैक्स साइज हमारा नन है, मतलब मैक्स साइज हमने सेट ही नहीं किया है, तो क्यू तो अनलिमिटेड क्यू है, तो उसमें हमेशा स्पेस रहेगी. ऑलराइट. बट इफ हमारा जो गेट साइज है, मतलब जो अभी क्यू मान लो क्यू का साइज है हमारा 10 एंड self dot max size is not equal to, sorry, it's not greater than, it's equal to max size. मतलब अभी जो क्यू का मैक्स साइज है और जो अभी उस क्यू का एक्चुअल साइज है, मतलब जो क्यू का हमारा अभी जो साइज है एट दी इंस्टेंट और जो हमारा मैक्स साइज है वो इक्वल है, मतलब हमारी क्यू फुल है. So we cannot add anything. Sorry, it might have caused confusion due to the signs. Was it due to that, or is it fine now? Is it cool with you now?
Can you explain once more?
All right. तो 20 and 21 लाइन समझ में आई?
नहीं.
अच्छा, सेल्फ का जो मैक्स साइज है, मान लो हमारी क्यू बनाई, हमने एक क्यू बनाई है क्यू UE1, ठीक है, हमने उसको कोई भी मैक्स साइज दिया ही नहीं, ठीक है, तो ये फंक्शन चेक करेगा कि अगर सेल्फ का मैक्स साइज नन है, मतलब हमने उसको कोई साइज नहीं दिया है, तो मतलब हम उसमें कितने भी एलिमेंट्स ऐड कर सकते हैं, है ना. तो इसका मतलब है द क्यू हैज सम स्पेस, इट विल रिटर्न अस ट्रू. ये लाइन आई समझ में यहाँ तक? These two lines 20 and 21, ये हमें बोलेगा कि yes it's true, the queue has some space. All right. Now अगर हमारा जो मैक्स साइज है, मान लो हमारे क्यू में अभी 10 वैल्यू ऑलरेडी स्टोर्ड है, ठीक है, तो हमारा क्यू का साइज क्या हो गया 10, और हमारा मैक्स साइज भी 10 है, max size is also equal to 10. तो फिर हमारे पास जगह है क्या? नहीं है, तो इट शुड रिटर्न, हाँ इसमें भी हम if डाल देते हैं, if पार्ट डाल देते हैं, self max size इक्वल टू ये, मतलब इसका मतलब जगह नहीं है तो रिटर्न इट फॉल्स। ठीक है, मतलब मैक्स साइज, अगर मैक्स साइज अभी वाले साइज के इक्वल है तो हमारे क्यू में स्पेस नहीं है, तो रिटर्न इट फॉल्स। ठीक है, डिड यू गेट दैट? इफ self dot max size is lesser than is greater than self dot get size, अगर सेल्फ डॉट मैक्स साइज मतलब जो मैक्सिमम साइज है, मान लो मैक्सिमम साइज है 12 और अभी हमारे क्यू में साइज कितना है 10, मतलब 10 एलिमेंट्स है, तो हमारे पास जगह है, तो इट देन इट विल अगेन रिटर्न व्हाट, रिटर्न ट्रू। ओके,
तो फर्स्ट वाला केस में
फर्स्ट
अनबाउंडेड क्यू है।
हाँ फर्स्ट वाले केस में यहाँ पे अनबाउंडेड क्यू है।
अच्छा ठीक है।
और ये वाले एल्स वाले केस में बाउंडेड क्यू है। ठीक है, तो इस पूरे को हम सिंपल थोड़ा प्रोग्रामिंग कॉन्सेप्ट्स के साथ इस पूरे को एक लाइन में भी लिख सकते हैं। ठीक है, अब मतलब ये तो थोड़ा पाइथन का और जनरल लॉजिक का है, तो दैट आई वोंट एक्सप्लेन नाउ। Let's move on to enqueuing part. But to get it now, you can replace this line and keep that also, the whole thing that we just discussed. Yeah. All right. Let's come to the enqueue part. Ab enqueue mein we have three cases. Listen to these three cases very diligently. First case is case one. Case one is that अगर if list is full, लिस्ट अगर फुल है तो what will it cause if we enqueue, कौन क्या हो जाएगा, ओवरफ्लो हो जाएगा। Isn't it? अगर लिस्ट ऑलरेडी फुल है और हम उसमें enqueue फंक्शन करें तो ओवरफ्लो हो जाएगा, तो हमें इसको टैकल करना है while coding. Case 2 is if the list is empty, अगर लिस्ट इज empty, अगर लिस्ट empty थी और हमने enqueue किया तो अब लिस्ट सॉरी क्यू एम्प्टी थी, if queue was empty and we add some element to it, तो what we have to take care that जो अब element हमने add किया है वो इकलौता element है, तो that same element is also the head and it's also the tail. Element is the head and the tail, so we have to set this. ठीक है, case 3 is that it was a general list which had some, some elements already, or maybe more than one element. So in that case, we can simply, make the new element as the tail. So tail would be added as the new element. Tail would be the new element because हम add queue में कैसे करते हैं, पीछे से, we add from the behind, so the tail would be the new element. So these are the three cases that we need to take care while defining a queue. Are these three cases clear?
Yes.
All right. So let's code it then. So just a minute. All right. So we need to tackle these three cases. Let's do it. So for the first case, हम लोग check करेंगे if the queue is has space or not. मतलब queue full है कि नहीं. So we can use the has space function if self dot has space. इसलिए हमने ये functions बनाए थे, नहीं तो we have to do all the logic has space का logic भी over here. So that would have been very good. So to remove that, so if the queue has a space, मतलब अगर queue full नहीं है, if the queue has any space, then we will do the part. Else, we will simply say that print no more space or something like that. Right? Maybe an overflow. Okay. Now let's. So this we have tackled the case one problem. If queue is full वाली, तो अगर full होगा तो we will output this no more space problem and we won't do anything. ठीक है. Now let's tackle the second case. If queue is empty, so but before that let's do the thing. So let's make a variable item to add, and this should be a node because we always add a node to the queue with a value. So this would be the item that we add. So how would we add actually? If now adding maybe two cases hai. If queue is empty, then we do this. If it is not empty, then we do this, only this. So let's do that. How can we do that? We can check if self is empty. T If self is empty, what do? We set the tail and head to the new element. So self dot head would be equal to item to add. Also self dot tail would be equal to item to add. ठीक है? Else if the queue is not empty, मतलब उसमें more than one element है, तो only self dot tail would be equal to what? Item to add. Also हमें लिंकिंग करनी पड़ेगी, वो नोड लिंकिंग. फॉर एग्जाम्पल अभी हमारी क्यू ऐसी थी 4 3 and we are adding I to the end. हमें एंड में ऐड कर रहे हैं आई. तो नाउ हमें क्या करना पड़ेगा, फोर्थ का जो प्रीवियस नोड है, फोर्थ का प्रीवियस नोड वी हैव टू सेट इट टू आई, एंड आई का जो नेक्स्ट sorry, I का जो next node है, we have to set it to 4. And since it's a singly linked list, so we don't have that previous node value problem only. So let's do what do we do? Dot set the next node item to add. Have to keep it below this. Can someone tell me why we have to keep this line below this line? Self dot tail equal to item to add. Why do we have to keep it below setting node? मतलब मैं I've set fourth का next node to I. ठीक है? I've set fourth का next node to I. Now after that, I will make I as the tail node because I'm using the tail over here. All right. So this is the basic reason. Now what else do we have to do? If I've added something, I have to also increment the size. So for incrementing the size, what I'll do is I say that size equal to size plus one. So this is it with the NQ part. We've we've tackled all the three cases and we've added something to the tail. All right. Coming to the DQ part now. Defining DQ function. Then it will only take the self, or it won't even take the self, right? Or should it take self? Tell me, will NQ take self or will DQ take self? Someone? Please, someone can tell me. Wait a minute, am I audible? Yeah. Ah. So, can someone tell me what NQ would take and what DQ would take? Samragni? Pratham? Anyone? All right. So
Both
DQ
will
में
take
we
self, I
all right. But one function is still missing a thing.
Yeah,
NQ
NQ will
or
take value also.
exactly it will take value also because हम कुछ को तो remove करेंगे ना कुछ को तो add करेंगे DQ में तो it will simply अगर 1 2 1 2 4 है तो it will simply remove the last simply remove the first one है ना but if we NQ something we'll have to add some value also. Now while doing this DQ function, again we have some cases. First case, one if Q is empty. Empty. What is the problem with Q being empty? If Q is empty and we DQ, it will cause an underflow problem. All right. So we have to tackle this. The second thing is if Q has an element, for example, if Q is not empty, if it has a single element Q. What do we need to do then? What we need to do is that we have to set the size of the Q equal to 0. And we also have to set the head and tail to none. That is basically the same thing. We have to set the size of the Q to 0. Now, in the case 3, the usual case where we have more than one element in the queue. What do we do over here is that whatever the element is left, we set it to the head. That is the previous element head. All right. So these are the three cases that we need to tackle while defining the DQ function. So let's code the DQ function. Wait a minute, I guess some disturbances. All right. Sorry, guys. So let's code it now. So for the first case, I will check if the size is if self dot size is greater than 0. That means if it has some elements, then only I'll do the removing part. Removing part over here. अगर उसमें elements ही नहीं है, else what do I print? I'll print that underflow problem. Underflow problem is there. Can't remove. अगर खाली है तो I cannot remove, right? So this thing. Now inside this if block, I will cover some the general thing, the second and the third cases. If it is a single element Q, that is if the size is equal to 1. So what I will do, I will set the head and tail to none, and that will do the thing. Else if the size is not 1, then I'll set it to the new head. All right. So let's do this. Before that, I'll set one new variable item to remove as again the node, but it's already a node, right? It's inside a queue, so I need not set it to anything. I will simply set it to self.head. That the new node that is to be removed would be the head. This time, while doing the same thing in NQ, we made a new node because we were adding a new node. But this time we are removing it. So जो भी queue में है, it is already a node, so we need not do that. All right. So now this, let's see if self dot size is equal to 1. Then we set self dot head equal to what? And also we set self dot tail equal to none. All right. Else, if this is not true, what we do is we simply we simply do the linking part. What do we link? जो भी head है, उसका जो next node है, self dot head का next node. So what to get that? I'll use get next node function. So जो self dot head का get next node है, उसको I'll set it as the new head. So self dot head है, that would be set to self dot head का next node. And this line. And also, if I'm removing anything, I will say that self dot size is decremented. So self dot size is self dot size -1, or I can simply use minus equal 1. All right. So this is the simple removal case that I could do. Is it fine, guys? This is the simple DQ function that we just did. We covered all the 3 cases. कि अगर empty है तो we show this underflow problem. Then अगर single element है तो हम remove तो करेंगे, but we'll set the we'll set the size equal to 0 and we'll set the head and tail equal to none. तो size तो 0 इसी से हो जाएगा, इसी line से for both the cases, but we'll set the head and tail to none. Also अगर इसमें more than one element है तो कि usual case है तो we'll set the previous element as the next node. मतलब जो head node का जो अगला जो node था, जो आने वाला node था, that will be the new head. So that is what how we defined the DQ method. Now the next method is the peak method. So peak method क्या करता है? Can someone remind me what does the peak method do?
Just return the first element.
Yes, exactly. So I can say peak. This will again take the only self because it has nothing to do with value or anything. It will simply return me what it will return me self dot head. Alright guys, is it okay? Self dot head भी नहीं, actually it should return me the self dot head key value because self dot head would be nothing but just a node. So we need not see the node or the memory allocation of the node. We just need to get its value. So self dot head की value बताएगा ये हमें. All right, but let's
Self.size equal to 1 will represent when queue is empty.
please can you repeat?
In the else part, self.size minus equal to 1. What is it representing? Just the
It will
queue.
representing that if this loop, if cell's size अगर बड़ा है, and if we are removing the list, we are removing one element from here to here, right? So if we are removing anything, we need to decrement the size. So इसको I could write that this should be equal to cell dot size minus. So that is all we've done there. Elsewhere, we are not removing anything, so we are because simply printing the underflow problem. So this is the peak method. But what if the list is already empty? So I can also improvise the peak method that the list if the queue is empty. If is empty, that is if the size self dot size is equal to 0, then tell the list is empty. The queue is empty. Sorry guys, I'm using list so many times. It's empty. And if it's not true, that is if the queue is not empty, then return this thing. Right. So this is the optimized peak function that we have here. So now we've defined peak, DQ, and NQ functions. Let's try to use it. Just use. Yeah. So over here, what they've done is they've made a scenario of a restaurant. So on the restaurant, they have a scenario that people are coming and they are giving their orders. So whenever someone gives an order, they NQ it, and whenever the order is delivered, they DQ it. So for example, uh, they've NQ'd egg and cheese on the rolls and bacon and stuff like that, and they've NQ'd several orders. So this would be the egg and cheese should be the one to be DQ'd. So when we print the line Delhi line is the actual queue. So when we DQ it, it should remove the first order, that is egg and cheese on a roll. Then again, when we DQ it, it should remove bacon, egg, and cheese on a roll. Let's run it and see if it shows that. So first, when we add, then what it does, it's adding to the orders. It's adding egg and cheese. It's adding bacon, egg, and cheese on a roll, and it's adding similar. Now, when on the serving part, egg and cheese on a roll is served. So egg and cheese on a roll is DQ to at first position. Then bacon, egg, cheese on a roll. Then toasted sesame bagel, and similarly, respectively, it's showing. So this is how this is. Now since the last is bacon, egg and cheese on a roll, it's served. Bacon, egg and cheese on a roll is served. So now the list should be, the queue should be empty. So now if I add another line of Delhi line.dq, it should show some error. The queue is totally empty. So you cannot, you could not do this. It showed us. All right. So this is simply how we do this. Do the implementation of a queue. Now there are some quizzes. There's a quiz for queue also that I've prepared for you guys. Do it, try it, and ask me any doubts if you have. Queues.